So today I'll be giving a tutorial on making bubble semantic maps, which is a vocabulary strategy for learning new terms. So behind me I have an example of a bubble semantic map for dog. So dog is my central vocabulary word. You're going to want to write that, or you can also make a picture in the center. And then stemming from your central word, you're going to want relating subcategories. So for mine, I had what do they look like, and my other subcategory, types of dogs. And you'll want to have relating words or phrases stemming from the subcategories. So from what do they look like, I had tail, furry, and 4 legs and paws. And then from the subcategory types of dogs, I have Springer Spaniel, German Shepherd, and English Bulldog. Bubble semantic mapping is a way that you can learn new vocabulary by relating it to prior knowledge and previous terms that you already know. Today we'll be going over how to make bubble semantic maps by relating it to relationships, examples, and facts. Bubble semantic maps are a great tool for learning new science vocabulary because it helps students link the new words to previous schemas that they already have. I will be using 6th grade as my reference grade. In the state of Michigan, according to the grade level content expectations for science, 6th graders are learning about earth science and types of rocks. Therefore, I'm going to make a bubble semantic map for rocks. I'm going to start by writing our central vocabulary word in the center, which is rocks. I'm going to circle it, and then I have to decide on my subcategories. I've already gone through the book Rocks and Minerals by Neil Morris, and I picked out 3 different types of rocks that I can use. So my subcategories is going to be igneous rocks, metamorphic rocks, and sedimentary rocks. So I'm going to start by stemming those out of our central word and writing igneous rocks, metamorphic rocks, and third, sedimentary rocks. Now that we have our subcategories listed out, we can focus on our 3 parts of bubble semantic maps. So first we can focus on facts, which help students understand the knowledge or the word better. So I've gone through, as I said, and looked at these terms. So I looked at the page for igneous rocks, and I found the terms, the phrases, igneous means fire, or fiery. I've also found that it's cool and hardened magma. Now we can move on to facts of our subcategory metamorphic rocks. So one fact is that it's a changed rock, and also that it's changed through heating or being squeezed, or both. Next we can move to facts about sedimentary rocks. So I found that they were formed by particles that have settled at the bottom of bodies of water. And then another fact about sedimentary rocks is that there are layers squeezed together. Second, we will go on to focusing on examples. In the case of rocks, we're going to look at specific names of different types of igneous rocks, metamorphic rocks, and sedimentary rocks. It's important to use examples because it gives connections that students can relate to, and it also gives a better understanding that these are just broad names for a bunch of varieties of specific types of rocks. So, in Rocks and Minerals by Neil Morris, I again found a lot of great examples that I can use. So for igneous rocks, I found that some specific ones is granite, and pegmatite, cyanite, gabbro, and peridotite. And then some examples that I found for metamorphic rock include gneiss, quartzite, slate, marble, and schist. And then I also found examples for sedimentary rocks. Some of them include sandstone, limestone, and shale. Lastly, I will be talking about any of the relationships I found. Relationships are any links or connections that occur. These are important because the more links that you have between vocabulary, the stronger the neural connections in the brain will be, and the more easily it can be applied and used. So some of the relationships that I found: igneous rocks, I found balancing boulders, in England, and the wave rock in Australia. I have a picture of both of those. Here's the balancing boulder. And then at the top here is the wave rock in Australia. And then out of granite, this is what makes the half dome in Yosemite Park, which I also have a picture of. There inside is the half dome at Yosemite Park. I'm also going to make an arrow connection going from igneous rocks to metamorphic rocks, and I'm going to write can change into, because igneous rocks can change into metamorphic rocks. And I'm also going to do the same thing from sedimentary rocks to metamorphic rocks. Because sedimentary rocks can also change into metamorphic rocks. And out of marble, I'm going to put Taj Mahal, which is in India, and it's actually made out of marble. You have a picture of that to show. Just right here at the top. And I'm going to write that marble is also changed from limestone. And then stemming from schist over here this is changed shale. And then I'm going to move on to sedimentary rock. And an example or relationship is that the painted rocks in Oregon are made from sedimentary rocks. And I have a picture of that. Here's the painted hills, painted rocks in Oregon. Another one is the sandstone arch in Utah. Right here. From limestone, this is what the Great Pyramid in Egypt is made from. Which can be seen here. So you can see this is a bubble semantic map that we made from using just one resource. If you have a topic that you think you need more examples, relationships, or facts, you can always use additional resources. Some of these may include extra books, internet sources, or articles that have containing information. For this particular topic, some additional resources that would be great to use is Our World by Richard Spiergen and Fiona Watt, and also The Magic School Bus Inside the Earth by Joanna Cole, and illustrations are done by Bruce Dugan. So when you are making your own bubble semantic maps for various topics, you want to make sure that you're looking for facts that provide knowledge, your examples that provide concrete understanding, and the relationships that will create connections and deeper understanding. Thank you for watching my tutorial. I hope this helps you in making your own bubble semantic maps.